Okay, Assalamualaikum. Okay, so this is the main subchapter for this topic. So the speed control. So the important to control the speed of induction motor because basically the induction motor itself is a constant speed machine. So by having a proper speed control technique, so actually we can have a wide range of speed, whether it is above normal or below normal speed. Speed control of induction motor. So recall that the synchronous speed Ns of the rotating field in an induction machine is given by Ns is 120 F over P, where P is the number of poles and F is the frequency of the supply. So you can see that by changing the frequency or changing the number of poles will change the synchronous speed for sure. So at the same time, the motor or rotor speed will also changes. The actual speed of the induction motor is given by N is equal to 1 minus S times Ns, where S is the slip. So by looking at the equation of Nr or N, which is the rotor speed, it shows that by changing the slip value also can change the speed of an induction motor. So that we basically can control the speed of induction motor by modifying these two elements. So number one, by varying the synchronous speed, or number two, by varying the slip. So the synchronous speed or rotating magnetic field speed can be varied by changing the number of poles or by varying the electrical supply frequency. So meanwhile, to change the value of slip is by either varying the stator voltage or terminal voltage, and secondly by varying the rotor resistance. So again, to change the synchronous speed, Ns need to change either frequency or number of pole. To change slip, need to vary the stator voltage or rotor resistance. Okay, now let's go to the detail on how to change the synchronous speed method. So approach number one, pole changing method. In pole changing method, the speed is varied by effectively changing the number of poles. So the change of poles is achieved by designing the stator winding such that the connection of the various coils, the terminals of which are brought out, can be changed. However, the poles can be changed in a fixed ratio. For example, if the poles are changed by 2/1, twice synchronous speed result. So means that we have a limited option to change the number of poles because of this 2:1 step ratio. Only discrete changes in speed can be achieved by this technique. A number of independent windings are needed to achieve different synchronous speed. However, due to size of the slots, the number of independent windings that can be placed in the slots of stator are limited. So to understand this, let's look at this figure. To understand the general idea of this method, let's look at this figure of a single phase winding in a stator. So by changing the current flow in one portion of the stator winding as such that it is similar to the current flow in the opposite portion of the stator, will automatically generate an extra pair of poles. When the current enters from the right side and leaves the winding at the left side, will produce north pole. So on the other hand, it is vice versa, will produce south pole. So on the other hand, the consequent poles also will be produced with the same concept due to the magnetic field effect. Only with the same magnetic field direction will not produce any pole. So figure A, in the two-pole configuration, one coil is a north pole and the other a south pole. So you can see that only 2 poles is produced by this setup. So you can see that from figure A, in is from the right side and out at the left side will produce nose pole. So however, when in from the left side and out at the right side will produce south pole. So in this case, in between there are no consequent poles generated because both are pointing upward. So for figure B, when the connection on one of the 2 coils is reversed, they are both north poles and the south poles are called consequent poles, and the winding is now a 4-pole winding. So for figure B, we reverse the point of enter for lower coils, so it will produce extra 2 poles. So in from the right side and out at the left side will produce north pole. The consequent poles is produced in between these 2 coils because the effect of the magnetic field. So in from the left side and out at the right side so will produce south pole. So the second approach to change the synchronous speed is by varying the frequency. So this method is very effective because the motor can be controlled in a stepless way over a wide range of speed. We can change the frequency at any level that we desire to match the requirement. The higher the frequency, the higher the speed of the motor. So 3 basic types of variable frequency supply that normally used to change the frequency level are variable frequency motor alternator set, DC link inverter, and C cyclo converter. Changing the electrical frequency would also require an adjustment to the terminal voltage in order to maintain the same amount of flux level in the machine core, because flux must be kept constant as F. F is the electrical frequency is varied to avoid sharp increase in magnetization current IM. So in this figure, you can see that the standard circuit arrangement of converter-inverter circuit. Converter in this figure represent the rectifier circuit. So the supply from TMB basically have a fixed voltage level. So for 3-phase is 400 volt at 50 Hz frequency. Then it will be converted to variable DC voltage. DC link will be used to filter and control the DC voltage and current in a variable frequency drive. Then the DC voltage will be converted back to AC voltage through the inverter, but this time the voltage and frequency can be changed according to the requirement. Then the variable voltage and frequency will be fed to the induction motor. So in this slide, they explain the whole concept of variable frequency method. Since the synchronous speed is directly proportional to the frequency, varying the frequency of the supply is an effective way of varying the synchronous speed of the motor. So again, the higher the frequency, the higher the speed. A continuous or discrete variation of speed can be easily achieved by continuous or discrete variation of the supply frequency. So means that whatever the speed of induction motor that we desire to have, we can achieve by changing to the specified frequency. However, main disadvantages of this method is the supply frequency is usually fixed. So this is the 50 Hz frequency supply from the TMB. Varying supply frequency requires expensive power electronics equipment. So maybe this statement is true long time ago, but now maybe it is not too expensive anymore because a lot of companies have developed this system. So this figure shows the detailed device used in variable frequency method. You can see that overall system consists of the rectifier circuit, the DC link or DC bus, and also the inverter circuit. Okay, now we move to the second method, which is variable slip method. So they also have two approach, varying the stator voltage, and second one varying the rotor resistance. So first we discuss the approach of variable stator voltage. So for this approach, the electrical or supply frequency is kept constant, but voltage will be varied when supplied to the motor stator. The developed torque of an induction motor at any slip is approximately proportional to the square of the applied voltage. So as we have derived in the previous lecture, so this equation, so torque is roughly proportional to the square of the stator voltage. So this method is simple and economical, but the motor losses increase with increase in slip, achieved by means of phase control of the anti-parallel thyristor. So by this way we can control the RMS voltage of the stator voltage. So this equation have been discussed in the previous video. You can see that the torque mechanical is proportional to the square of the supply voltage. So in this slide, you can see how we put the anti-parallel thyristor for each line of supply that deliver the voltage to the stator side. Anti-parallel arrangement because we need to control the AC voltage for both positive and negative cycle. In this slide, you can see other arrangement of AC voltage controller. A, delta connected controller, and B, neutral connected controller. But the focus is still the same, to control voltage received by the stator side. Example 4 will be discussed in the next video together with the method for solving equation with degree of 4. Slide 89 and 90. So next, second approach on variable slip method is by implementing variable rotor resistance. So this type of speed control is only possible for slip ring induction motor. So it is not applicable to cage rotor or squirrel cage induction motor. Next, the maximum value of torque does not depend upon the value of the rotor resistance, but rotor resistance influences the slip at which maximum torque occur. So refer back to the previous video. The equation of Tmax does not contain R2, but to calculate Smax, yes, adjustment of R2 will affect the maximum slip. The slip is increased by increasing the value of rotor resistance as seen in figure A. So in this figure, R2 triple prime is the largest value of the rotor resistance. So the more the maximum torque occur towards to the left side, so the higher the value of slip will be. Also, you can see that based on the intersection with the torque load curve. By having this approach, there are two techniques that can be implemented. The first one is by adding external resistance to the face of a slip ring rotor as shown in the figure. Okay, the mechanical contactor can be used for this method. So the contactor are used to shut out portion of the total resistance step by step for different level of speed. Next approach is by using chopper resistance. So with the development of thyristor, it has become possible to use a chopper control resistance in the rotor circuit. So the working principle of this approach is by varying the duty cycle, which in turn varies the effective value of the resistance. Inductance is added to the circuit to reduce the ripple and discontinuity in the DC link current. So point number 2, resistance can be varied from 0 to R by varying the time ratio of the chopper. So the resistance will be 0 when the chopper is on and will be equal to full value if the chopper is off. So in this last slide of speed control topic, shows that for the method of variable slip method, we can combine both approach, stator voltage control and rotor resistance control, to increase the range of speed control. So on the stator side, use stator voltage control. On the rotor side, use chopper control.